Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximize, minimize and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hi everyone, my name is Abel and I'm a Principal Cloud Advocate and the DevOps Lead at Microsoft. And I'm super excited to be here presenting on getting started with DevOps session. Now, this is the first of 5 sessions in the DevOps learning path, where we give you an in-depth look at the how, why, and what it means to run a successful DevOps strategy in your organization. So in this session, we'll be looking at getting started with DevOps. For this entire series, we will be outlining issues that need to be solved within a company called Day1 Traders. And just what is going on with Day1 Traders? They've been growing rapidly, and senior team members have recognized that differing goals across teams has caused a rift in communication and collaboration. So they've started an initiative to implement a DevOps strategy to help with collaborating across their growing teams. So the first thing they'll look at is things like source control, better collaboration tools, and shared tooling in general. And today, we'll discuss how each of these will enable their teams to be successful and grow right alongside their application and customer base. In this session, we'll be covering things like what is DevOps and why is it a good fit for Day1 Traders. We'll talk about source control with an introduction to Git and GitHub. And we'll take a look at how Day1 Traders can use Microsoft Teams as their collaboration hub. And we'll talk about how they can extend their DevOps experiences by using Visual Studio Code. Now, before we get into tooling, what exactly is DevOps, right? Because if you ask 10 different people, guess what? You're probably going to get 20 different responses. At Microsoft, DevOps is something very specific to us. So at Microsoft, DevOps is the union of people, process, and products to enable the continuous delivery of value to your end users. Now, I said this very carefully because every word of this definition has meaning. Now notice I didn't say continuously deliver code, because what will that give us? Piles and piles of code sitting on a source control server somewhere. Who cares, right? That does nobody any good. And notice I didn't even say continuously deliver features, because again, we could be delivering feature after feature, sprint after sprint. But if it's not what our end users need or want, we're just wasting time. So the key here is we have to continuously deliver value and doing whatever it takes to be able to do this. But why, right? Why is this so important? Well, the speed of business today is so ridiculously fast that the only way dev teams can keep up and innovate fast enough is if they adopt DevOps best practices. And the sad truth is, if you don't adopt DevOps best practices, your competitors, they either have or they will. And once they do, they will out-innovate you. And when that happens, you become obsolete. And none of us wants that to happen. So this used to be DevOps theory, but we've been doing this long enough now that we have empirical evidence that shows teams that adopt DevOps best practices absolutely out-innovates teams that don't. But it's not easy to do right. To do DevOps correctly, you must address all 3 pillars, right? The people, the process, and the products that help enable everything. Now, the people pillar, that's a cultural shift that needs to occur where everyone from the very top of your organization all the way to the bottom, everybody is hyper-focused on continuously delivering value, no matter what it takes, where any and all walls and areas of frictions, they're knocked down to allow continuous delivery of value. And we need processes in place that will let you innovate fast enough, yet still deliver code of high enough quality, where you have frequent iterations so quick course corrections are possible, where you have automations in place to speed up this process and to reduce human error, where even when your app reaches production, it doesn't end there. Because you still need to monitor your app. You still need to know, is my app up or down? Is my app performing well? And what are users really doing in my app? Because those things can help me identify, am I delivering value? Sprint after sprint after sprint. And based off of that, we can course correct in our next iteration if we need to. And guess what? Agile processes, they work perfectly here. And finally, we need products, right? Tools that help enable all of this. And one of the most fundamental and important tools is source control. Now, source control is a form of version control. It uses the concept of code repositories to track changes on all artifacts within the repository. It enables cross-team collaboration through things like branches, versioning, commit history, and code reviews. One extremely popular and useful source control protocol is called Git. A Git repository, at its core, is a collection of files and folders that comprise a product or application. Some common things you'll find in a Git repository are things like the actual source code for the project, a .gitignore file that allows you to tell Git to ignore certain files you're not tracking, and branches that allow you to isolate development from work from your main or production code. So this allowed developers to work on things in an isolated area without affecting a live code base. And changes within those branches can later be merged back into the main branch as work gets completed and reviewed by your team. Now, commits that track changes to the artifacts within the repository so that now you can better understand what changed, when it changed, who changed it, and why it was changed. And tags, which point to a specific release of your code base. Now, the true beauty of source control is the ability for an entire team to work on that same code base without stepping on each other's toes through the use of branching, merging, and versioning. Now, the most well-known and the leader in Git repository hosting is GitHub. Now, some of the features that make GitHub so awesome include the ability to track things like issues, bugs, and features across your project. Also, the ability to more easily share and collaborate expertise by encouraging comments and communications at various steps of code writing. And the ability to easily set up a whole bunch of integrations with other surfaces like Microsoft Azure. And you even have the ability to do work inside a hosted instant, fully featured dev environment through code spaces on GitHub without ever having to leave your browser. Now, one of the most powerful features inside of GitHub is GitHub Actions. This allows teams like Day1 traders to automate their software workflows with world-class continuous integration. So what this means for Day1 traders is they won't have to worry about manually kicking off builds, testing, and deploying to validate their products are ready to be deployed. So with a little setup, GitHub Actions can handle that and make sure their product is all bundled up and ready to deploy as developers submit pull requests, also known as code reviews, to their projects. And all of this means the developers at Day1 traders have a more streamlined process for delivery of their applications. So less time spent on mundane tasks and more time spent on doing what they do best, which is writing code for their projects. So what are some of the things you'll find in a GitHub project that you won't find in a standard Git repo? Well, first, you have a README markdown file that allow teams to better document the project within their repository. Also, a security markdown file that allow teams to define their security policy. A license file that defines the license for this project, and code owners file that allow teams to define who is responsible for what parts of the code base. Pull requests also are super cool because that allows you to request to merge a set of changes that exist in one branch into another branch. And this feature also allows teams to double check work and communicate changes before they're merged into the code base. So issues is another thing, right? Issues allow you to track things like bugs, features, or general requests within your code base. And bundles of specific iterations of your projects, those are referred to as releases. So let's take a quick look at GitHub in action. So as you can see, Tailwind Traders, they've uploaded their website as a project on github.com. And this project is called Tailwind Traders-website. So this is the main branch, and this is the source code that exists inside the main branch. If we click on the main button over here, we'll see I have a whole bunch of branches, and we also have a license file. And we can see that we are using the MIT license. We also have a readme.markdown file, and this file gets rendered down below and shows information about this repository. So things like requirements, prerequisites, ways to deploy the project, specific information about this project that I think collaborators need to know. So this is a very important step in creating your project in GitHub. Now, across the top, we have tabs like this pull request that shows all the open pull requests, which are requests to merge changes from one branch to another. And this is where our team can collaborate and review changes together before they get merged into our main code base. All right, let's go ahead and check out the Actions tab. And this is where you would go to set up or manage your action workflows. So things like CI/CD, which is continuous integration and continuous delivery. We also have the Security tab, and this shows things like your security policy and advisories. Now, if you don't have a policy, you can set it up here by clicking Start Setup. So you click this button, and this will pre-populate with a sample security policy.markdown file. We can click on the Preview button, and now we can see how the markdown will be rendered, and we can see our policy shows supported and unsupported versions, and it also shows how to report a vulnerability. And if I wanted to, I can commit this file right to the main branch, or I could use DevOps best practices and create a new branch for this commit and start a pull request. And I can do all of this right here from within my browser. All right, let's take a look at the insights. And here you can show different analytics about your projects, information about your community, traffic, commits, how many pull requests you've had, things like that, right? And in the settings, this gives you access to things like managing access. So you can see I've added Able to this project here. And you can set up security and analysis features as well. And you can change your default branch name if you want to. You can set up protection rules where you can disable force pushing and branches from being deleted. You can also set up webhooks, which allow external services to be notified when certain events happen. And you can see I've set up 2 webhooks already for notifications within our team. And under the Notifications tab, you can set up who will actually get notified, right? You can either put in emails or an entire list. You can also set up different integrations, deploy keys, actions and permissions, moderations. Ooh, check out the moderations. This is kind of neat. This is where you can restrict users from interacting with your repository for a 24-hour period. All right, let's go back to pull requests, and we'll check out a pull request that Able did. So here, he added a security.markdown file to the project, and he created this pull request to get permission to merge his changes from his personal branch into the main branch. Now, when we go into the Conversations tab, you can see that there has been one commit that added the security.markdown file. And this is where continuous integration and testing would have run with GitHub Actions if it had been set up. You can also see this branch has no conflicts with the base branch, which means if we click that merge button, it will just merge cleanly into the main branch. Now, if we go to the Commits tab, we can see one file was added, and if I click on File Change, I can literally see everything that was changed. And I can also click here to leave an inline comment. And when I add this inline comment, it's going to create for me a review request. Now, if we go to the Conversations tab, we can see this review request in detail, and you'll see this yellow box, right? This shows this is in review, and I've started a conversation. So now here is where the rest of the team can weigh in with comments and suggestions before they allow this merge to go through. Or someone can come in and approve this, which would allow the merge to happen. All right, let's look at a pull request that I created myself. And as you can see, we can drill into the commits, and I can see I created a file, and I can go to the File Changes tab. And here I can leave a comment for myself, and I can still start a review process even though I created the comment. Now, if we go into the Conversations tab, you'll notice that I can still see the review section. I can still leave comments, but I am no longer able to approve my own requests. And this reinforces best practice around having your team peer review every change before merging. All right, let's look at adding and removing code. If we click on the Add File button, here we can create a brand new file or upload new file all directly from the browser. And if we click on this code, this is where we can create a repo locally, right? So let's go ahead and do that. If I type git clone with that URL, it's going to pull down my remote repository and stick it on my machine. And I can cd into this directory, and that will take me to my repository on my machine. Now, following best practices, you never want to make changes to your main or production branch. So let's go ahead and create a brand new branch. I'm going to add a collab.txt file. So let's call this branch collab-file. And I'll do this from the browser. And we just created a brand new branch, right? So now let's pull this branch down locally. So I'll issue the command git pull. And this will pull that branch down. And to use this branch, we can check it out by saying git checkout collab-file. And now we're in the collab file branch. Now it's based off of the main branch, so you're still going to see the same files. But now when we do work, we're in that isolated branch. So we're going to create that collab.txt file. And once I do that, let's do a git status. And you'll see that we have a new file, but it's not being tracked. And that's because collab.txt didn't exist previously. So we need to add it, right? Let's issue the command git add collab.txt. And this will tell Git to start tracking this specific file. And now when we do a git status, we'll see that there is a change. We added the file and it's ready for a commit. So we'll go ahead and do a commit, which is git commit-m with a short message that tells us what this commit was for. And once that's done, we'll do a git.push, and this will push those changes back into the browser, or not browser, back into GitHub. So we'll jump back to the browser to take a look at what that looks like. So it says, guess what? Collab file, it had one recent push less than a minute ago. If I refresh this browser, we'll be able to see the collab.txt file, and bam, there it is. So that's awesome. So the next step is to get my changes into the main branch, right? So which means I have to create a pull request. So I'm going to go ahead and leave a comment here. Let's say adding a collab.txt file. And you can see it's going from the collab file branch to the main branch. And I can go ahead and create that pull request. And now we open up the conversation and it's checking for the ability to merge my changes automatically. And under the file changes, I can enter a comment to start a review of this pull request. And now that I've started that review, I can start a conversation, right? And here, my team can now jump in, review my code, and give me suggestions. Or if everything looks good, they can go ahead, approve my changes to be merged into the main branch. So right there, that's a quick run through of GitHub and how to use GitHub for both source control and for your pull requests. So Tailwind traders, they have GitHub projects for their applications, and they're on the right track now. But there are other things they'll need to keep track of as well. Things like communications with the team, calendars, conference calls, meetings, files that they use. So how can teams like Tailwind traders more easily collaborate across their organizations? So this is where Microsoft Teams comes in. Microsoft Teams is the hub for teamwork. Some key features that make Microsoft Teams so great are the ability to chat, meet, call, and collaborate from anywhere. And with a full Microsoft 365 integration, you can easily schedule meetings, check out your calendar, and join conference calls directly within Microsoft Teams. And if you need to chat with your teammates, you have instant messaging built in across your organization as well. Microsoft Teams can also be extended with countless integrations for other applications and services. And by using Microsoft Teams, Tailwind Traders is able to simplify and effectively amplify collaboration across their entire organization with minimal effort. And speaking of integrations, Microsoft Teams has an integration for GitHub via the GitHub for Teams app. It allows you to subscribe to projects within GitHub to get updates on issues, inspect commits, collaborate on pull requests, and much, much more, and all without ever having to leave Microsoft Teams. You can also add a tab at the top of a channel so the entire team can more easily track things like pull requests. And this integration allows teams like Tailwind Traders to more easily collaborate on changes within their code base without having to jump back and forth between different applications. Another awesome integration within Microsoft Teams and GitHub is the GitHub Enterprise app, because this allows you to set up a connector that sends notifications directly into a specific Microsoft Teams channel about updates and changes that happen inside of your GitHub project. You'll be able to track changes live in a channel and watch and interact with things like commits and pull requests. And what the connector sends into the channel is, of course, completely customizable through a webhook in your GitHub project. So let's take a quick look at Microsoft Teams in action. As you can see, Tailwind Traders, they've started to configure Microsoft Teams as their collaboration hub. So first, they created a Tailwind Traders team, and you can see if I go to manage this team, they have lots of members and guests that are invited, and I can see their roles, I can change their roles, I can set tags, locations, things like that. And under the teams, we have a general channel for general chatting. We have an Azure board web channel for Azure boards activity. And we also have a GitHub web channel for GitHub activity. Now let's take a look at the general channel, and you can see notifications are already happening from the integrations that I've added. If we go to the Files tab, these are the files we have in our SharePoint. And if I click on this file, it will open up this file where I can start editing it right here inside of Teams. And if I want to, I can open it on the desktop, or if I want to view this in SharePoint, I can simply click on Open in SharePoint, and it will take me directly to my SharePoint site. We've also integrated with OneNote, so here's my OneNote notebook. And under here, you can see we're capturing meeting notes right now. We've also set up a SharePoint tab, and this will show us any files we create inside the SharePoint for our team. But what about meetings and conference calls? Well, let's take a look. So you can see here that we have a fully integrated calendar, and all my information is right here in Teams. And if I needed to join one of these meetings, I can simply right-click on it and join without needing to leave the Teams experience. And what about calls? Yeah, I can do that as well. I can accept calls, I can make calls, and I also have integration to a whole bunch of third-party applications, things like OneNote and SharePoint, and also GitHub. And speaking of GitHub, I've configured GitHub to send me updates from our GitHub projects in real time into our chat. So this helps me keep an eye on things that I care about. We also have this GitHub tab, right? And this will show us all of our live and open pull requests. So those are open and closed for our project. I also wanted live updates to happen in our chat channel, so I used the GitHub Enterprise connector to send these live updates from our project right here into our GitHub web channel. Now, we didn't want to flood the general chat with this type of activity, so that's why we created this separate channel. I've also created an Azure Boards web channel, and we set it up very, very similar to how we set up this GitHub web channel. So this channel is showing us updates inside of our Azure boards where we can keep track of things that's going on, right? So this is our Azure boards, and we're doing all sorts of stuff, right? We're tracking all of our work items for our project. And as work is being done, right, as it's being moved, as work changes, as things get assigned, all of these changes are actually reflected right here in the Azure Boards web channel in the chat in real time. And this makes it really easy to see what's going on without having to leave the Microsoft Teams experience. Now, we've also configured the Azure DevOps app to show our board right here inside of Teams. And what's even better, you can do real work here. You can move items, assign things, make updates, all right here without having to leave Teams. And just like before, you can see these things happening in real time in the Azure Boards web channel. All right, I noticed a moment ago that Abel had moved one of these tasks to the done column because he completed it, right? So here we go, there it is. So that tells me there's probably a pull request that's open. So let's go check. We'll pop on over to our GitHub web channel and we'll look at the pull request tab. And as you can see, 5 hours ago, Abel opened up a pull request because he added that security.markdown file and he wanted the team to review it. So here I've started the review process for this pull request, telling the team, hey, let's go ahead and review it. And it looks like he's adding that sample.security.markdown file. And that's totally fine for us because, we're just starting out with this file. So I'm going to go ahead and add a comment and write him a comment telling him, hey, everything looks great. And I'm going to go ahead and merge this. So I'm going to set it to approve and submit my review. And now that that is all done, you can see there is one approval, and I'm going to go ahead and merge this pull request. And after clicking merge pull request, you see there's a note here about the merge that's about to happen, and I'll go ahead and confirm it. And you'll see that the pull request was successfully merged into the main branch. Now, if we go back into Teams, the web channel, you'll see all the updates have happened in real time, and it's been reported right here inside the channel. And this freaking rocks, right? Because the beauty of this is the rest of the team, they didn't have to be inside of GitHub. Now they can see these notifications as they're doing their daily work, and these notifications happen right inside of Microsoft Teams. Now that we've taken a look at GitHub and Microsoft Teams, we're going to take a look at Visual Studio Code and how that can help Tailwind traders. Visual Studio Code is an open source free text editor. The source code, it's on GitHub, and you can download and run this app on Windows, Linux, and Mac. And it has Git commands built right into it. It also has language support for all kinds of languages through extensions. Now, these extensions, they can be found in Visual Studio Code Marketplace, where there are literally thousands of extensions. Extensions for all kinds of languages, extensions for tooling support, extensions for connectivity and deployment, and extensions that support multiple cloud, not just Azure. So here's an example of a cool extension. This extension is for the Azure CLI, and you can create a script with the Azure CLI which lets you use the command line to do just about anything inside of Azure. Now you can save this file as a bash file, as a shell script, as a PowerShell script, or as a .az CLI file. Now if you save it as a .az CLI file, that's when the magic happens, right? Because you get IntelliSense and code snippets that you can use inside of your code. It also has integrated terminal, and you can create a side-by-side editor to make sure your CLI script is doing what it's supposed to do. And you can get documentation on mouseovers as well. Here's another cool example. This is the GitHub pull request and issues. Now, Git capabilities for push, pull, and other basic Git commands are built right into VS Code, the core product. However, GitHub-specific things like tracking issues and pull requests, those are not. But you can download this pull request extension, and now you can do things like review and comment on pull requests, and validate pull requests, and check out users. And these are all built. There are also some built-in actions to start a branch or create issues from to-do comments, right? So a really powerful extension. There's also a live share extension pack that's super, super cool. This lets you code and collaborate in real time with anyone else that has VS Code. They need VS Code and the Live Share extension pack. And you can do all this live coding with both video and chat. So enough of flipping around through slides. Let's see all these cool things in action. So now Brian Benz is going to come. He's going to jump in and show us the power of Visual Studio Code.
So here's Visual Studio Code, and I'm working on a site called Tailwind Traders website. This is a local clone of something that I have on GitHub. And basically the code is here on the left. There's something I'm editing on the right, in this case a YAML file. And here's the GitHub capabilities that we have built into it, which I'll be demoing a little bit. The extensions that I mentioned before are here. So these are the extensions I have enabled, and then they make recommendations on other extensions. There's also the GitHub pull requests extension that I mentioned. And here's, for example, pull request created by me, and it's got all kinds of information in here about the pull request. This is actually me doing a reverse pull to bring in the latest version of Tailwind Traders from the main site. So let's have a look at that on GitHub and see what it looks like. So here's the Tailwind Traders website on GitHub. And as you can see, it's forked from Microsoft Tailwind Traders website. I've got several commits that I've done, and you can see over here on the right, it's 40% JavaScript, 31% CSS. It's got some C#, some PowerShell, some HTML. It's got a shell script in there and some other, which is Node.js and a couple other things. So basically what I'm going to do is I'm actually going to edit some actions that we have created, and we're going to push this to a website that we've already set up. So I'm actually going to go down here. If I look at my code, I want to change this. Instead of saying deploy to website, I want to call it deploy to staging website, because we're actually deploying to a staging site up here. It's called Bbenz Tailwind Staging. So let's save that. And if you'll see over here on the left, it tells me if I go into my built-in GitHub capabilities here, I've got one change, which is main YAML, and that needs to be committed. So let's say I change deployment to staging. All right, I saved that. If I click the little checkbox here, it's going to tell me it automatically commits it, but I forgot to stage it. So this is one of the nice things about Visual Studio Code. It reminds me, hey, you have nothing staged to commit. Do you want to stage your changes and commit them? Yes. So it will actually commit them. Now I have different options for actually getting this out to the GitHub repo. Remember, this is my local clone. So I can just push, or I can do a sync. I really like doing the sync because it pushes and pulls any commits. So if this is being worked on collaboratively, I make sure that I have the most recent versions from the upstream. Okay, so now the change is gone and it's been committed. So what happens, this is a GitHub action, and it's a GitHub action on push. So what's going to happen is when you actually push out to the repo, an action will be triggered. So let's check out that action. The action's actually working. So let's watch that run. And let's actually go into the build and have a look at that. So right now it's installing dependencies, and then it's going to build. So let's just wait for that build and make sure it succeeds. Looks like the build went through, the test went through, and now we're going to publish. So in a few seconds, this should actually publish out to the website once we get down to the deployment stage. Oh no, looks like it's failed at the publish stage. Unfortunately, I'm not sure why. Let's scroll through here and see if we can find out exactly what the error message is. One of the things that is possible at this point is that this is a GitHub Actions environment. It's a very standardized environment that GitHub Actions uses, but maybe there's some special things set up in our development environment that this would run. So for example, this might work on a developer's machine, but for some reason it doesn't work in the GitHub Actions generic environment. So there is one thing we can do to test that out. And it looks like in this case, it's not a problem with NPM, but there is a error on node SAS, which looks like a dependency on Node. So I know it's something to do with Node. But before I go too far into debugging this, why don't I try running it on a customized environment and see if that works? So to do that, I can actually use something else that's inside of GitHub. If I go straight into my Tailwind Traders main site, I can open with code spaces. So code spaces for GitHub is a way to create a standardized environment that you can reuse. So let's create a new code space. And what that's going to do is it's create a space based on the parameters that my organization has set up inside of here. And there might be something special in here that wouldn't run in the generic environment and allows me to publish and deploy this. So it takes a few seconds to start the code space, but once that's done, it's going to build a container and it's going to run the container, and then I'm going to have everything in my environment here just the way it looked in Visual Studio Code. Now here we are. It's just opening the code. So basically, if you look over on the right, it initializes a code space, builds a container, runs the container, and then it configures the code space for you. So it basically does a clone into this environment, and it creates this container in a environment that can be reused later. So now we can check out this code, and we can see here, for example, we have issues with Tailwind Traders Web, and let's go in and see what that is. So yeah, looks like the object release, something to do with the attributes here. Yeah, it's very odd. So this isn't going to work even in this environment. Unfortunately, it's not going to work. There's just something wrong with the build and the way it publishes. It's very strange that it worked when you did the build, but not the publish. So let's check out another way we can do this. And by the way, I'm showing you this from GitHub, so code spaces on GitHub from the web. There is another way to access that, and that is through the remote extensions. If you go to Visual Studio Code over here, there is a way to connect to code spaces here, and that'll be the code spaces on GitHub, but you'll be opening it in a new version of Visual Studio Code. It'll look pretty much the same as it did in that environment that I just showed you. All right, so the next thing we want to do is we want to figure out, I'm at the end of determining, end of my skills and abilities at determining what is exactly wrong with this build. So what I'm going to do is I'm going to connect with a colleague and see if he can help me. This code obviously has some issues. I'm going to need some help figuring out exactly what those issues are. So because I installed the LiveShare extension pack that I mentioned earlier in the slides, I can actually start a live collaboration session. And it's copied to my clipboard now. So what I'm going to do is I'm actually going to phone a friend. I'm going to phone my colleague, Zach. And Zach's going to hop on the line and help me figure this out. So let's do that now. Calling Zach.
Hey, Brian, what's up?
Hey, Zach, how you doing? You got a few minutes?
Sure. What's going on?
Okay, cool. I've got an issue with some code. I can't quite figure out exactly what it is, and I could really use your expertise. So I'm sending you a LiveShare link. You should see it in the Teams chat now.
Yes. Okay, let me join that.
Okay, cool. Great. I'm going to take you off this screen. All right, so let's have a look at the code now. So Zach has joined the collaborative session, so great. So here's the code, basically. It's a GitHub action, and it seems to be failing on Node. I'm not sure exactly why, but I was hoping you could help me out there.
Yeah, so it looks like you have your node version set to 14, and it might build in that environment, but I think your target environment requires an older version. So let's try node 10.
Okay.
And see how that goes. I'll save this for you.
Beautiful. Thank you, sir. All right. So if we go back into our GitHub controls here, you'll see that there is one change, and it's already populated a comment here, which is co-authored by Zach. So change to node 10. All right. So what I'll do is I'll commit, and I forgot to stage. So one of the nice things about Visual Studio Code is it reminds you, hey, you don't have anything staged. So yeah, I do want to stage that. And then I could just do a push, but I always find it safer to do a sync. So sync does a push and a pull using the built-in Visual Studio Code commands. And that goes out there. You'll see when this blue finishes that it's actually pushed to the repo. One thing before we leave Visual Studio Code, I did want to mention inside of LiveShare, I could do an audio call as well if I have multiple people and maybe they don't have Teams set up. But for now, I just kept it simple, and Zach and I are talking on Teams instead of joining the chat here. So good to use the tools no matter what you have. There is a way to share the audio. So let's go over to the GitHub action now. If we go in here to the website, if I check actions, as expected, I see that it's running as co-authored by Zach, and the build is in progress, and should just take a couple of seconds to go here. All right, looks like publish happened. That is farther than we got before, so this is great. So let's just check out and make sure it publishes to the website. Well, looks like we published to the website. Let's go back in there and let's check this out. So it should be this URL, should be able to open it. Let's go in a new tab. Yeah, it looks like the website's loaded. Fantastic. So we solved that problem in a second. That's what collaboration is all about. Thanks very much, Zach, for your help in that live collaboration session.
No problem, Brian. Have a great day.
All right, you too. Thanks.
Thanks, Brian. Man, that was a very cool demo showing the power of Visual Studio Code, code spaces in GitHub, and also LiveShare. Okay, so we've covered a lot in this session, so let's do a quick recap. At a high level, we covered how laying a solid foundation for a DevOps strategy can help solve the issues that Tailwind Traders has been facing. And now that Tailwind Traders has a story for source control, collaboration, and shared tooling, they are on the right track to continue down the path of a full DevOps solution. So we also talked about what is DevOps, what is source control, with a quick intro to Git and also GitHub. We discussed how Microsoft Teams has enabled more effective collaboration across the Tailwind Traders organization. And we looked at how Visual Studio Code can help solve problems with shared tooling and even more collaboration. So if you'd like to take a deeper look into what DevOps is with overviews, tutorials, samples, and more, head over to aka.ms, all things DevOps, where you'll find our DevOps Resource Center. And if you'd like to explore the collection of Microsoft Learn content for the AZ400 Designing and Implementing Microsoft DevOps Solution certification, head on over to aka.ms Getting Started DevOps. If you'd like to learn more about getting certified, you can head on over to aka.ms/AZ400cert. So, thank you all so much for joining us, and join our next session too, Managing the Flow of Work. In this session, we'll be covering how Tailwind Traders manages their flow of work. Tailwind Traders, they've gone all in on DevOps. They've read about it, they've studied it, they've gone to classes on DevOps. They 100% believe this is the way going forward. And in the last session, getting started with DevOps, Tailwind Traders, they've even decided on their tooling stack. So now they're ready to start DevOpsing. But what exactly is DevOps? You ask 10 different people, you're going to get 20 different responses. At Tailwind Traders, they decided to adopt Microsoft's definition of DevOps. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. Now notice, I said this very carefully because every word has meaning. Now notice I didn't say continuously deliver code, because what will that give us? Piles and piles of code sitting on some server somewhere. This does no one any good. And notice I didn't even say continuously deliver features, because I could be delivering feature after feature, sprint after sprint. But if this is not what my end users need or want, why am I wasting my time doing it? So the key here is we need to continuously deliver value. It is 100% vital that Tailwind Traders continuously delivers value. But why is this so important? Here's the thing. If you haven't adopted DevOps best practices, your competition, they either have or they will. And when they do, they will out-innovate you. And when that happens, it's game over. You will quickly become obsolete. And none of us wants to be obsolete. Now, this isn't just DevOps theory. We've been doing this long enough now that we have empirical proof. Organizations that adopt DevOps best practices absolutely out-innovate teams that don't. And not just by a little bit, but by a lot. And this is why Tailwind Traders needs to adopt DevOps best practices. But it's not easy to do right. In order to really adopt DevOps best practices, you have to address all three of these pillars: the people, the process, and the products. Now, people, that's a cultural change that has to occur within your organization, where every person from the very, very top all the way down to the bottom must be hyper-focused and aligned on continuously delivering value. For the process, we need a process that will let us iterate fast enough, yet still deliver code of high enough quality. Now, finally, we need products that can help enable all of this. And at Tailwind Traders, they've got the people and the culture down, right? Everyone has been trained, everyone is aligned and believes in DevOps, everyone is prepared to do whatever it takes to continuously deliver value. They've even got their products and tools down, as you saw in the first session. So all they need to do is just figure out their process. Now, in order to continuously deliver value, they need a process that is highly iterative, yet still delivers code of high enough quality. And it needs to be highly iterative because they want to have many frequent small releases versus infrequent large releases. This way, they can continuously deliver value. Now, with many small iterations, they also have the ability to course correct really quickly. Now, we don't always know if what we're doing is what the end users really wants or needs. So if we have a lot of small iterations, we can now make a hypothesis, spend, let's say, 2 weeks implementing it, release it to the public, gather telemetry to see if end users really value this new feature. And if they do, hooray for that. We can double down on features like this or even expand upon this feature. And if they don't, not a big deal, because we've only wasted 2 weeks versus months and months and months of dev time. We will just reprioritize the backlog and then rinse and repeat this process. So what kind of a process will let us do this? Agile and the many flavors of Agile. So things like Scrum, Kanban, Agile with a capital A. Now, personally, I'm a massive fan of Scrum. I love Scrum. I'm a Scrum purist, and I've led several successful dev teams using the Scrum methodology. And I'm not saying any of the other flavors of Agile aren't good, because they're all good, they work. But today, we're going to be looking at Scrum. In Scrum, everything starts with your backlog. And what's a backlog? Think of it as a prioritized wish list of everything you want your software to do. So the most important things are at the top, and the least important things sink to the bottom. Now, at the beginning of a sprint or an iteration, the product owner will go ahead and prioritize that backlog. And then the team will commit to doing part of that backlog based on the priority and what they think they can get done. And then they'll spend the sprint working. They'll burn down whatever bugs are found in sprint. And at the end of the sprint, they'll show what they've accomplished to the product owner in a sprint review meeting, and hopefully they'll push into production as well. And based on the sprint review demo, the product owner then will reprioritize that backlog, and this whole cycle can rinse and repeat itself. So that was a super quick description of Scrum. So let's dive in a little bit deeper and look at some general principles. First of all, this is not a waterfall project. We don't build the entire thing and then release it. We build it up incrementally, so sprint after sprint, building the highest priority items on the backlog first. And we do this because this allows the product owner to look at what we're building at the end of every sprint. And when they do, they can now give immediate feedback. So this here is vital. Most of the time, people don't really know what they want their software to do until they start clicking on the buttons. Because you notice how people are super quick to tell us what they didn't like versus what they want their software to do. So by building our software incrementally, we can now have frequent inspections of our software and immediately course correct as needed. So instead of wasting months of work, the worst that could happen is we waste one iteration and then we course correct. So super powerful, super useful. All right, next in Agile or Scrum, everything should be transparent. The dev team, they're not working in a vacuum. The product and sprint backlogs should be public, where everyone can easily see what the team is currently working on and what the team will most likely work on next. Transparency and communication, again, is another key part in Agile and in a DevOps world. Next, I wanted to touch on what makes up a Scrum team, because there's only 3 roles. First, there's the product owner. There's literally one job for the product owner to do, and that is to prioritize the backlog. The first thing I tell a new product owner is that this is not a waterfall project. Again, we don't ship when everything is finished. In fact, most likely, we won't ever get to a point where everything on the backlog is finished. So hopefully we'll be shipping at the end of every sprint. So we need to make sure that the most important features are prioritized so they get done first. Prioritization, and then the course correction that comes from reprioritizations, that right there, again, another key concept inside of Scrum. Now, in order to be able to prioritize correctly, the product owner has to be able to make decisions on how that product will function and what it will look like. Or said another way, the product owner has to have a vested interest in the end result of this piece of software. The success or failure of this piece of software must directly affect the product owner. Next, there's the Scrum Master. Now, the Scrum Master has 2 roles. First is to make sure the team follows Scrum best practices. And second, it's to protect the team, the Scrum team, from outside interference. You ever get that high-level exec that walks up to a dev directly and tells them, I need you to add this feature immediately, right? And of course, this messes up everything from the planning to the scheduling, so on and so forth. It's the job of the Scrum Master to protect their team from people like the high-level exec. They need to be able to tell them, nope, you don't get to do that. You can't drop something on us mid-sprint. Put it on the backlog, you can rank it really high, and we can tackle it next sprint. Finally, there's a dev team. This team, it needs to be cross-functional. When there's someone on your team, you need to have people on your team that can do whatever, whenever that needs to be done for the project. And the more cross-functional your team is, the better it is. Now, I know in an ideal world, every person on the team can pick up any work on the backlog and just get it done. In reality, most people are not 100% full stack, right? But you just need to make sure there are team members that can cover tasks, the different types of tasks. However, we do strive to be cross-functional. So sure, we do each have our own areas of specialty, but don't let that stop us from grabbing tasks, learning, and growing. Let me give you an example. I was once on a project where I finished up all my tasks, and I'm a back-end dev. The only remaining work on the backlog was some crazy SQL query. Now, I do know SQL, but I'm really kind of good enough at it to be really dangerous, right? That's the level that I'm at. So yes, I did pick up that task, but I also pinged my teammate, who is an expert at SQL, and I asked them to pair with me. Because now they can make sure I'm not doing anything crazy or wrong, and I can also learn from them. This will help me ramp me up. It will upskill me on my SQL skills. All right. Finally, these Scrum teams, they should be self-organizing. No one needs to direct a Scrum team on how to do the work, what they need to do, so on and so forth. They can figure that type of stuff out for themselves. All right, writing software, it is like a three-legged stool. You can have quality, you can have a date you're done, and you can have features. And guess what? You can only move two of those things, right? And in a software project, quality is not negotiable. You cannot skimp on quality. So what that means is if you want more features, you must move the delivery date out. And if you can't move the delivery date, you're going to have to reprioritize the features that you're going to ship with. It is that simple, and there are no exceptions to this. Also, when you're planning, estimates, they're not guarantees. And although the more you do it, the better you do get at it. So estimates, they've always been a bit fuzzy. But to help with your estimates, here are my rules. I want to break down all of my work into 4-hour chunks. Why 4 hours? First of all, it's a lot more accurate. I'm pretty good at estimating things within 4 hours. I'm pretty good at estimating even a day's worth of work. 2 days of work? Yeah. More than 2? All right, more than 2, I'm starting to guess. Now, my go-to estimate, if you ask me how long it will take to do something, I'm always going to say 2 weeks. Why 2 weeks? Because I think I can write just about anything in 2 weeks. I can probably write an entire OS in 2 weeks. But to be really accurate, I'm only good to about a day or two. And I've been doing this for over 20 years. All right, so next, if we break down a user story into 4-hour chunks, there's now a possibility that instead of just one person spending 3 days working on this, this can be split up into a lot of small tasks, and my team can work on it in parallel, which means we can potentially knock this user story out much faster. Also, with much finer grained tasks, it is so much easier to track progress. So if I just have a task that's 2 weeks long, when I look at my board, how do I know work is progressing, right? Because we've all done this, where on day 1, we can say, hey, we're 20% done. And after day 2, we can say, hey, now we're 60% done. And then on day 3, we're at 90% done. And for the rest of the 2 weeks, it just stays at 90% done. And at the end of the sprint, we're still not done. So if you break down your tasks into 4-hour chunks, this lets us plan and track work so much better. And finally, never start from a date, right? Because developers, we're pleasers. We want to make people happy. So if you start from a date, we're going to magically subdivide the work up so they'll fit in the allotted time. Even though this doesn't work and is not accurate, it's kind of what we do. So don't start from a date. Work out the task, break it down into 4-hour chunks, and then see where the end date lands. Finally, the rules apply to everyone. In order for Agile to work, everyone in the organization must be hyper-focused and aligned. So remember, the whole point of us moving away from Waterfall to Agile is we finally admitted that Waterfall does not work well for software projects. In fact, 90% of Waterfall software projects flat out fail. And by fail, I mean they go over budget, over time, too many bugs, or the end result is not what the end users want. So we know the old metrics and the way of doing things is garbage. We must all be aligned now with how things are done and measured in an Agile world. Everyone, from the very, very top all the way down to the bottom. And no one is exempt from the rules, no matter what their title is. Okay, so Tailwind traders, they get Agile. They get Scrum. But to do Scrum right, they need tools that will help them track their work from sprint to sprint to sprint. They need to be able to easily reprioritize work on the backlog, as well as track their work both within a sprint and across sprints. And all of this needs to be easily accessible by everyone, because remember, no one is working in a vacuum, right? The product backlog, the sprint backlog, the current product plan, those need to be publicly available. And guess what? Azure Boards, linked to my GitHub repo, does a great job of this. So let's check this out. In the world of Agile or Scrum, everything starts from the backlog. So here's my backlog, and as you can see, it's an ordered list of everything that I want my software to do. Adding new work, I can just click the new work button, I can give it a title, add to the top, and there it is. Now, if I click on this particular work item, it opens up a form and I can give more details. So I can give things like descriptions, acceptance criteria, etc., etc. Now, if I want to prioritize my backlog, that's as simple as just dragging and dropping on this board. Now, the other thing people use the backlog for is they choose the work from the backlog and say, this is what I want to do for a particular sprint. So they create a sprint backlog. In creating, that's easy enough. I can just go ahead and multi-select, and then I can just drag it and drop it to the sprint that I want. And if I click on the sprint, it will take me to my sprint backlog. Now, my sprint backlog behaves exactly the way I expect it should. You can now prioritize work by dragging and dropping. I can add new work as well. And the other thing it can do is I can break down my work into the individual tasks that I need to complete this item. So again, tasks, remember, they should be 4-hour chunks, right? So for this particular work item, let's say I need to update my database schema here. And I also, let's break this down a little bit more. Let's say I need to update my API layer. Awesome. So pretty cool, right? Now I have my work item. I've broken it down into 2 individual tasks. I love backlogs, both the product backlog and the sprint backlog. They're great at adding and prioritizing work and doing breakdowns. But where they start falling down is tracking work as it's happening. Now I want to be able to track my work as it happens, and I want to be able to do this visually, both within my sprint and across sprints. And you can totally do this with Azure boards. So the first thing that we're going to check out is the task board. So here it is. Here you can track what your team is doing within a sprint in a visual manner. You can drag it and drop it, and you can see what's going on. Super, super cool. Now, if we zoom back out a little bit, we can see at a higher level what a team is doing from the Kanban board. So this is a fully customizable Kanban board that shows the ongoing state of my project. And I really love this board because now in one place, I can easily see what's going on in my project. I can also see when a work gets stalled in a particular column. And when I notice that, I can now redirect my team. We can swarm on that particular unit of work. There's also deep integration between the work items created in Azure boards and also with GitHub. So let's go check out this deep integration between the 2 systems. So let's bring up GitHub. And if I make some changes to my file, all I need to do is format my commit message in a certain way. So let's pretend I'm doing work for work item number, how about work item number 425, all right? So in my commit message, I just need to say, let's say doing some stuff, this is where the magic happens, fixes AB pound 425. Now, check out what happens when I click the commit buttons. Look at the board, and bam, did you see that? How cool is that, right? The work item magically flew over to the done column because of that deep integration with GitHub. But wait, there's even more than just that. Let's take a look at this work item. This work item is now linked to the specific commit in GitHub. If we click on this, it's a deep link into GitHub that will take us directly to our comment or our commit. And now we can see exactly what we did in the GitHub UI. Super, super cool. This deep integration between Azure boards and GitHub makes working really, really nice. Okay, Tailwind traders, they're now almost ready to start diving into code, but they still have one process question, which is what branching scheme do they want to use? Now, traditional branching schemes involves a lot of long-living branches. So you've got dev branches, QA branches, feature branches, UAT, main, etc., etc. And having all these long-living branches, it's not conducive to moving quickly. Like anytime you need to merge code from one long-term branch to another, boom, a merge bomb goes off. And guess what? Sooner or later, you're going to get a code conflict. And fixing these merge conflicts is not easy or pleasant or quick to do, right? This is extremely painful and an expensive problem that everyone will run into if they use long-running branches. So to solve this problem, Tailwind traders, they've decided to use trunk-based development, where they're basically deving and releasing right off the main branch. So the way they do this is when a dev picks up a user story, they create a topic branch, do their initial work, and they very quickly merge that topic branch back into the main branch. With no long-running branches, there's almost no merge bombs. And any conflicts that do exist, they can be solved really, really quickly. So easy peasy, right? Problem solved. But Some of you might be thinking, how can this possibly work, right? If you're practically deving off the main branch, how are they not just introducing bugs all over the place? They solve that problem by using a software technique called feature flags, or feature toggles or switches. So feature flags is a technique that lets you turn on or off certain portions of your code during runtime. In one deployment, you can now ship alternate code paths, and during runtime, you can pick which path you want to go. So this is awesome because what that means is you've now separated deployment of your code from the delivery of your new features. So this starts making things super, super flexible. Because of that, every new feature and every new bug fix Tailwind Traders writes, it must be wrapped in one of these flags. So now they can check into master without fear. As long as a flag is off, the new code does not get run, only the old code. All right, from a code perspective, there really isn't anything magic with feature flags. They're glorified if statements. Actually check that. They're not glorified if statements. They are literally if statements. They really are super easy to implement. So I've come across a lot of companies, when I tell them about feature flags, they'll be like, oh, feature flags, it looks really cool, right? But we're not ready to use feature flags. Our application isn't architected in a way to support feature flags. That's just ludicrous, because if your architecture supports an if statement, guess what? Your app, it's ready to use feature flags. And once you start using feature flags, you can now start doing some really cool advanced DevOps stuff. For instance, you can do things like A/B testing, where a percentage of your traffic runs in variation A and a percentage of your traffic runs in variation B. And now you can grab the telemetry and figure out which one is delivering more value, right? Very powerful. You can also use feature flags to do something called safe deployment, where you only turn on the flag for a really small percentage of your traffic. And you make sure everything still looks good and works for just that small percentage of your traffic. And then you can open up your flag a little bit more and make sure that works, and open it a little bit more until you're very sure everything is good, and then you can turn it on for your entire traffic. Finally, another thing you can do with feature flags that's super cool is if something goes wrong with your latest deployment, rollbacks become super easy. All you got to do is just turn off your flag and voila, you're done. The new feature, that's what rolling out is. That's all it takes. All right, so enough talking about feature flags. Let's see them in action. So what you're looking at is my resource group in Azure that holds the resources for this particular project. And one of the resources is going to be an app configuration, right? So this will hold all the configuration for my application, including my feature flags. So to look at my flags, we'll go to feature management, and notice I have one feature flag right now, and it's called the new about flag, and it's currently in the off position. So if we jump to my application and we refresh this, okay, here it is. Look at across the top, there's an about tab, and it just says about. If I click into it, that's my current about page. Hooray for that. All right, let's jump back to the portal, and we're going to turn on our particular flag. So here's our portal. We'll turn on the flag. That's all it takes. Now let's jump back to the application, and we'll refresh. And now check out the about. Instead of about, it now says new about. And if we click it, it takes us to the new about page. Pretty cool, right? All right, so as you can see, these feature toggles, really easy enough to toggle it on and off while you're live, while your website is running. So you can also do this programmatically as well, turning the flags on and off using the CLI. Now to implement, super easy to do as well. So let me show you. Here's my code. You can implement your flags both in the view and also the code. So let's check out the view first. This right here is your standard .NET view. You can add a feature flag by adding this tag, the feature tag, with the name of your feature, and with negate is equal to true right here. What that means is if the flag is off, then go ahead and output this chunk of HTML. Otherwise, if the flag is on, the new about flag is on, output this chunk of HTML. So what this is saying is if the flag is off, just output about, and if the flag is on, you output the new about, right? That's what we saw. All right, so in my code, this is how you would implement it in code. So I'm using .NET, and these flags are supported in a bunch of different languages. You can do this in two ways. First is by adding this annotation to an action in your controller. So if the flag is on, this action, it will exist. And if the flag is off, this action, it won't even exist. You can also do this inline with the if statement. So here I can say if, and I use a feature manager object, if it's enabled, and I pass in the feature flag that I'm checking, and if that flag is enabled, go ahead and run this chunk of code inside the if statement. And if the flag is off, you do the else, right? All right, so to see this running, let's set a breakpoint, and we'll go back to the app, and we'll go ahead and trigger this. So let's jump to the home page, click on New About, and it will hit our breakpoint. Hooray for that. And now, when we walk over this if statement's going to evaluate, and you'll see that the flag is on, so it goes into the if statement and runs this chunk of code. Now, when we jump into the view, this is my About view. And if the feature is on, it's going to go ahead and output this chunk of code. And if the feature is off, like negate is equal to true, right, it's going to output this chunk of HTML. And if the feature is on, it's going to output this chunk of HTML. So, feature flags, they're super powerful and they're super easy to implement, both in your code and also up in Azure as well. All right, finally, Tailwind traders, they've got one thing that they're worried about, and that's quality. So moving as quickly as they will be moving, they're not going to have time to do full end-to-end functional testing. So they need to shift left and build quality into their app as they're writing it versus trying to tack on quality at the end, like the way traditional software is QA'd. So one of the things they did to improve quality is they're requiring every check-in to go through a pull request or a code review. However, they quickly ran into some problems with their pull request workflow. First, pull requests were getting lost in the shuffle. People would either miss or ignore pull requests, and they would start piling up. Now, there are some amazing benefits with pull requests, but if you don't do them immediately and they start piling up like this, your dev work comes to a grinding stop. Now, another problem they had when reviewing the code changes in a PR is that they really wanted to see the changes running in a live test system. But that's a lot of work, because what that meant is for each PR, they'd have to build the app, package it up, provision the infrastructure they needed, configure it correctly, then they needed to deploy the app into the freshly provisioned infrastructure. And now they can finally see those changes. And oh, when they were done with the PR, they really kind of need to clean up the staging environment too, right? Because otherwise they're just going to leave a giant mess. And that sounds pretty crazy. Like being able to do this for each PR, it would be awesome. But really trying to execute this would be a serious pain. I mean, who has the time or energy to be able to do this correctly every single time and to do it quickly? And that's where GitHub Actions comes to the rescue. So Actions, that's GitHub's workflow engine, where you can automate all sorts of things inside of GitHub. Just as an example, I created automation using Actions to help take care of Tailwind traders' pull request problems. So to solve the problem of PRs stacking up with no one really knowing PRs are there or waiting for them, what I did was I created a swim lane in our Kanban board, and I called this pull requests. And now whenever there's a pull request, I'll have GitHub Actions automatically create a pull request work item, link it to the GitHub pull request, and I'll put it into the Kanban board into the correct swim lane and the column, right? So this way, it is readily apparent there are PRs waiting to be looked at, and if no one picks it up quickly, as the Scrum Master, I can jump down my team's throat until someone finally does it. But wait, there's more, right? Next, I'll have this action automatically build and package up my application. And then, since I'm using Azure App Service to host my app, I'll dynamically create a staging slot named after my pull request ID, where I then deploy my application. And then, since the URL to my staging slot is dynamic and changes for each PR, I use Actions to write back to my pull request with a link to my staging environment for this specific PR. So this makes it super convenient for the person reviewing the pull request. And finally, when the PR is closed, I'll be a good citizen, and my action will go up, clean up, and delete the slot from Azure App Service. So this sounds kind of nuts, right? But we can totally do it. Let's check it out. So what you're looking at right now is all the resources for this specific application up in Azure. One of the resources is the app service hosting this application. So if we go ahead and look at the deployment slots for this specific application, we'll be able to see that I have one slot right now specifically for production. All right, let's jump into the Kanban board. And you can see that it's configured exactly the way Tailwind Traders want. So they have an emergency swim lane for live site incidences. So again, this way it's super easy for them to see. The team can swarm on live site incidences and they can fix it. It's very visual, front and center. They also have a swim lane specifically for pull requests. So again, they were having trouble seeing when pull requests happen, and pull requests were getting lost in the shuffle. So this way, it's really easy to see. It's on their board, front and center. Team members can see it and jump on and start doing their PR. The rest of the board is configured exactly the way Tailwind Traders wants it. And okay, so let's go ahead and create a pull request, and we'll make some code changes. So let's pretend this work that we're doing is for work item number 432. And instead of checking in directly, we'll create a branch. And then we'll go ahead and create a pull request. And as soon as I create that pull request, it's going to go off and kick off that automation that I have. So let's jump into the Actions tab, and we'll see the automation happen in real time. So here we are, automation's been kicked off, and now we can see in parallel, we're creating a new pull request work item inside of Azure Boards, putting it in the right place. Bam, did you see it? There it is. And we're also going to, in parallel, build my application, right? So when it's done building, it will then provision a new slot in my app service, and then it will deploy that newly built app into the provision slot. So this takes a little bit of time to do, so while this is running, let me show you how I configured all of this. Now, the automation is using GitHub Actions. And the way you set that up is off of your root directory, you're going to have a .github/workflows directory. And here's where you store the definitions of your workflows. And you're going to store it as YAML files. And I know nobody really loves YAML, but this one's pretty easy to understand. So first, you're going to name your workflow. So it's called name. And next is the on section. That's going to be your triggers. So I have two triggers. One of them is for pull requests. So anytime somebody issues a pull request to the master branch for open, synchronize, reopened, or close, it will go ahead and trigger this specific workflow. There's also another trigger called workflow dispatch, and this is just a manual trigger that I trigger from the UI. So I can use this to help me debug this workflow. The next section is my jobs, right? So the first job that I have is let's go ahead and create my pull request work item inside of Azure Boards. So that's what it does. Next, in parallel, I build my application. So I restore my packages from NuGet, I build my app, package everything up, I upload that package as a zip file back up to GitHub. Hooray for that, right? It's just a normal build. And now for my deploy stage, this is not going to run in parallel, right? Because I need to wait for the build to actually finish. So right here where it says needs build, that's where I'm saying wait until the build is finished, then go ahead and do your tasks. So what is this one doing? It's going to download my build artifacts. Then it's going to go ahead and get my pull request values from GitHub. So things like the title and the ID. And then I'm going to use the Azure CLI. So first I log into the Azure CLI. And then using the Azure CLI, I can create a deployment slot that's based off of the pull request ID. And when that's done, I can deploy my app into that specific slot. And when that's done, that's when I can go and create a comment into my pull request. So that's what I'm doing here. I create a comment back into the pull request into GitHub, and I give it the unique URL to the dynamically created slot. All right, and when I finally close this pull request, it's going to go ahead and clean everything up. by deleting the correct slot. So it does that by getting my pull request values, then using the Azure CLI, I go ahead and delete what I need. All right, so let's go back to my actions, and we can see that it looks like it's completed. Everything is green, that's good. So now let's jump back to the browser, and we'll go ahead and check out what really happened in our environment. All right, so first let's go back to the portal, and we can see, let's refresh this, and bam, there's a new staging slot with the ID of the pull request. All right, so now if we go back to our Kanban board, we'll be able to see that it's created a new work item, right? And if we click on this, this will take us into the work item. And this is super cool because you can see that there's a link, there's a deep link back into GitHub. So this links us back to the GitHub pull request, where now you can see it's adding a brand new comment. So we can click on it and we'll see, dun dun dun, we added a new comment that says created staging environment with a URL to my staging environment. So this makes it really easy for whoever is doing my PR. Now, if I click on this link, bam, it takes me to my app running in my staging environment just like that. How cool is that? All right, so not only does it do all of this, it does clean up, right? So if I go ahead and close this particular pull request, let's check out what should happen. It should clean up my staging environment, right? But again, automation is going to kick off, so we'll jump into actions. And you can see there it did. Automation has kicked off. And if we drill into it, we can see that it's now closing my pull request and cleaning up my staging slot. And it does that by deleting the correct staging slot from my Azure App Service. Again, this takes a little bit of time to do, so we'll go ahead and wait until it's done. All right, it's done. So now if we go back to the Azure portal, let's refresh this, and voila, the staging slot has now been cleaned up. Very, very cool stuff. Okay, so what I wanted to demonstrate with this specific demo is that I wanted to show that we can create a very intricate and complex workflow using GitHub Actions. And because Actions is so flexible, you really can make these workflows do just about anything, not just CI/CD. So go ahead, go and create automations to help enable your workflows. So this is super cool, man. Tailwind traders, they're now in a really good state. They have adopted the DevOps mindset, they've picked the products that will help enable DevOps, and they've implemented processes that will be doing what they need to do, right? So they've got everything now. They have the culture, the people, they have the process, and they have the tooling. So now the fundamentals, they are all in place, and they're now ready for some more advanced topics. So join us in our next session, Delivering Change in the Cloud, and we're going to dive into ways Tailwind traders can deploy into the cloud both faster yet safer. So we covered a lot today, so let's do a quick recap. At a high level, we covered how Tailwind traders will be running their projects using Agile and the Scrum methodologies. And Tailwind traders, they're going to be using trunk-based development with feature flags to be able to move at DevOps speed. And finally, using GitHub Actions as an automation engine, they've automated a fairly complex pull request workflow to help them move quicker yet safer. Now, if you would like to take a deeper look into all these DevOps concepts and more, head over to aka.ms/allthingsdevops, where you're going to find our DevOps Resource Center. Also, to get certified with AZ400 certification, head on over to aka.ms/AZ400cert. And to prep for the exam and to learn all the DevOps techniques in AZ400, head on over to aka.ms/gettingstarteddevops. And finally, to learn all things Microsoft, head on over to microsoft.com/learn. All right, thank you all so much, and I'll see you in the next session. going to be talking about a part of DevOps, which is delivering change to the cloud. Now, Tailwind Traders, it's an online hardware store, and their software delivery team and engineers, they've been getting much better at working as a team. They collaborate well using Microsoft Teams, and they consider security really early on in their process. And they even have continuous integration that runs all of their tests and ensures the quality of their code every time they check their code in. But when they make changes to their application, actually delivering it to customers, the deploying to production part, that's still really manual, and it gets delayed because it's really hard and it's super, super painful, right? It hurts every time they deploy because things break. So naturally, they start avoiding deployments. And after a bit, when they absolutely have to deploy, what was just one small change has now become lots and lots of changes, which of course just makes everything that much worse. And when the team finally does deploy, is all that work going to be worth it? And we really don't know until it's in the hands of our end users, right? Because we can spend a lot of time coding up features, and when it finally does deploy, our end users could be like, yeah, didn't really like that feature. And now we've just wasted all that time because now we've delivered zero value. So it's much better to fail fast and then course correct. Spend a small chunk of time writing code, quickly deploy, get feedback and telemetry from our customers, and if we are delivering value, that's awesome. Carry on, right? We can flesh out this particular feature. And if not, we can quickly course correct. So this works with DevOps perfectly because DevOps ultimately is the union of people, process, and products to enable the continuous delivery of value to our end users. So this is Microsoft's definition of DevOps, and value is the most important part. The earlier you can put something in the hands of your users, the sooner they can evaluate it and see if it's true value. Deploying every 12 months, that's not going to cut it, right? That's not going to give you the agility to change directions quickly. And we as an industry have learned that we're really bad at guessing what our end users want or need. We only really know when the feature is in the hands of our end users, either by directly giving us feedback or through telemetry. And that's why we constantly talk about continuous delivery, right? So in getting started with DevOps session, that first one, we looked at collaborating effectively. And then in managing the flow of work, we improved how our work goes from start to finish. But so far, we haven't really talked about delivering anything to the end users, and that's what we'll be looking at in this session. CI and CD, those are terms that are thrown around a lot, but they don't always mean the same to everyone, so let's go ahead and level set. CI is continuous integration, and CD is continuous delivery, or it could mean continuous deployment. CI is continuous integration, and it's all about ensuring your changes work with everyone else's changes. Or said another way, your changes need to integrate with everyone else's change. So whenever you do commit, a build should happen to ensure at the very least the changes you made still build with everyone else's code. Next, tests should run, right? Because you want to maintain your quality from one check-in to the next. So we try to catch our bugs as early on in the dev cycle as possible. But wait, there's more, right? There's more to it than just building and testing. Ideally, anything else you care about when it comes to building your app should happen here. So things like linting or security auditing or maybe even scans for credential leaks or whatever else you need, they can happen right here. So depending on what you're talking about, CD could be continuous delivery or continuous deployment. Continuous delivery means at the end of each automated CI/CD pipeline, you have a deployable application or a deployable piece of work, a deployable unit, and you can pick that up and deploy it at any time. So this should include scriptable environments as well, for instance, like infrastructure as code, where even if no environments are provisioned, or if someone manually went in and configured your infrastructure incorrectly, you have everything you need to stand up your application correctly at the end of this pipeline. Continuous deployment, that takes it one step further, and it actually deploys. So it may not necessarily deploy it into production. You might have CD into a test environment or a staging server with gates where you can promote this into production, right? But ultimately, continuous deployment is all about when you go to deploy your application, your pipeline is trustworthy and reproducible. You know the deployment into production is going to work because you did your deployments exactly the same way to your other environments. So my pro tip is always have continuous deployment to somewhere. Don't assume the version you just created is going to deploy as cleanly as the last version. So always deploy somewhere. All right, so let's talk a little bit about GitHub Actions. We've seen actions in some of the previous sessions. We've even seen examples of complex workflows around continuous integration. But we haven't really looked at continuous deployment with GitHub Actions. Now, we've seen actions can build our software, but what about deploying into production? So first of all, GitHub is an automation engine for any workflow related to your repository. And yes, we've been using it for CI/CD, but that's only one way to use it. You can run a workflow when someone comments on an issue, or when someone forks your repo, or even just on a regular schedule. In fact, there are dozens of different events that can trigger this workflow. However, it is very good at CI/CD, and it can deploy almost anything to almost anywhere. All right, so let's look at Day1 Traders again. Day1 Traders is a hardware supply company, and they want to make some changes to their application. So we're going to go through a CI workflow, and then we'll extend it to take it a bit further to deploy it all the way out to Azure. All right, so this is the Day1 Traders website, and the marketing team has told us this recommended here, not descriptive enough. They want us to change it to recommended categories. All right, easy enough fix. We'll jump into VS Code. We can change our translation file, and we can make the change here. All right, so after we make the change, we'll go ahead and save this, and we'll check our code in. So this is just git commands. We'll do a git commit, and then we'll push this back up to GitHub. Now, as soon as our code hits GitHub, it's going to trigger our workflow. And our workflow is defined in this specific YAML file. So as you can see, anytime code hits main, it's going to trigger this workflow. And this is just going to go ahead and build our application and then run our tests. So if we come into the Actions tab in GitHub, we can see this workflow has been kicked off. We can drill into it. And we can see, yes, all it's doing is it's going to build our application and test it. It is not doing any deploying of any type at all. So let's go ahead and jump back into our workflow definition, and we'll add some actions that will do that deployment. So the first thing we're going to do is at the very end of this workflow file, we're going to add some actions to do some deployment steps, right? So the first thing we're going to do is we're going to add a .NET publish step. And this will create my deployable artifact as a zip file. So it's going to be my web app all packaged up and ready to be deployed. All right, so after this publish step, we're going to add another step that's going to deploy the packaged web app to Azure App Service. So notice we're going to pass in the publishing profile of this app service as a secret, right? So we need this to be able to deploy. And we're also going, let's add one more task in between this. I want to be able to upload my build artifact to this specific release, because potentially I want to do something with this build artifact later on in this workflow, maybe like in another job, right? All right, so we've added that. We'll go ahead and save our changes, and we'll go ahead and commit these changes back up to GitHub. So again, this is just your normal GitHub workflow. We'll do a commit, and then we'll push. And once we push our changes up to GitHub, once the code hits GitHub, it's going to trigger our action. And let's jump into GitHub and see what it's doing. All right, so here's our action. It hasn't started yet. Let's click on Actions again. And there it is. Awesome. Our action is running. We can click on it, and we can see in real time everything that it's doing. So this takes a little bit longer to run because not only are we building and testing our application, we're also deploying as well. So as this is running, let's talk about some of the other options you can do inside of your build. So GitHub Packages is super useful if you are creating a reusable package that you want someone to download and use later. So things like Docker containers or NPM or NuGet packages, right? This is a great package management system, easy enough to use and add into your workflow. Another thing you can do with your build artifacts is you can upload it to a specific release. So this will allow you to upload your artifacts to a specific release as a downloadable artifact. And you can do that inside of your GitHub Actions workflow. And then you can download and use the artifact later on in your workflow, like, for instance, in another job somewhere. So here's an example of how you can do that. All right, in terms of deploying to Azure, there's all sorts of things that you can do with Azure as well. You go to the marketplace, search for Azure, and you're going to find piles of actions of things you can do inside of Azure. What's really cool is all of these actions, the ones written by Microsoft, they're open source. So the source code is checked into GitHub, and you can read the code to see what they're doing, or you can even submit pull requests if you want to add features or to fix things. There's also a lot of documentations around how to use these actions. But one of the best pieces of documentation is examples on how to use these actions in real YAML files. So if we go ahead, let's go ahead and scroll down over here and click on Azure Starter Templates. Here you'll see plenty of examples of workflow templates that actually use real Azure actions. And if we click on Azure App Service, now we're going to see a bunch of workflow definitions as YAML files for Azure App Service. So if you're going to do something, we probably have a sample that we can use. All right, jumping back to the build, we can see this process. It's almost complete. We've built our app, we've uploaded our artifacts, and now we've deployed our application as well. So if you look at artifacts, bam, there we go. We've really deployed or uploaded our artifacts back up to this specific deployment. All right, so now if we jump into production, we should see our changes, right? So let's refresh this, and instead of recommended, bam, it says recommended categories. Our change has now been pushed all the way out into production. So all we needed to do was check our code into source control, and automatically those changes were built, tested, and deployed into production. And that's great, right? But maybe we want to deploy the same app to lots of different environments, maybe even hosted in different places, like maybe hosted in Azure and also in our own data center, or maybe even in someone else's cloud. So guess what? Containers, they're a great way to do things like that. So we're going to remove all of this, and we're going to replace this with Docker commands. So what are we doing? We're going to build our application in a container, then we're going to containerize our application, then we're going to upload our container image into a container registry. So let's go ahead and do a commit, and we'll push these changes back into GitHub. Now, once we do that, that's going to, of course, going to kick off our action, our workflow, and it's going to run using this definition. So what is it doing? It's doing something pretty simple, right? It's going to go ahead and build our app in a container. It's going to create our application in a container. It's going to create an image for that, and it's going to upload our container image to a container registry. So let's jump into the Azure portal. We can look at our container registry. You can see we already have some container images here. That's awesome. And now if we jump back to the workflow, as soon as it's finished, that means it's uploaded our container image up to our container registry. So jumping back into our portal, this is our container registry. Let's refresh this. And now you can see our workflow added a new image to this repo. And we've tagged our images with latest, if it's the latest build image, and also with the SHA from GitHub. So everything is super traceable. And we also have an Azure App Service that's connected to this, and it's pulling images from this registry. In fact, every time there's a new latest tagged Docker image, it will automatically pull it down and deploy that Docker image into production. So bam, there's our code running up in production, just like that. So this is a super cool way, a super cool workflow of getting our code into production by using containers and container registries and hooking Azure App Service up to our container registry. Okay, so we've seen a couple different examples of pushing to production, but we probably don't want every one of our changes to go straight into production. Now, if we follow trunk-based development practices, working mainly off of trunk, then any commit to main branch, that's going to deploy to production, right? But we don't want that, at least not initially. We want some opportunity to verify that our changes look good and it doesn't break anything. So what are we going to do about it? We've spoken in other sessions about working with pull requests to make sure there's an opportunity to check any new code before it gets merged into the main branch. And as I've mentioned, there are dozens of events that can trigger workflows, and pull request is one of them. So now during a pull request, we can build that app, test that app, then we can deploy that app into a staging environment that's specific for that pull request. So now we can test the outcome of our changes before it's merged into the main branch. Or in other words, we're applying checks before merging back into the main branch. So there are quite a few trunk-based pull request workflows that work really well. But here's one that I really like. So this blue line here represents our trunk or our main branch. And as work gets done, a short-lived feature branch is spawned and work is done in there. So these short-lived feature branches, they represent the work we are doing, and it's important that they are short-lived. We don't want these branches to live for a long time. We don't want a month's worth of work stacking up inside these branches, because that's when merge bombs happen. So we're really talking about days here, max. Now, when we are ready to release or deploy something to production, we can create a release branch off of the main branch, and this will be used to deploy our code. And you can do the same thing with tags or with the releases. I really like using branches because branches are super cheap in Git, and it's also a nice way to archive everything that changes. And also, if we need to do hot fixes, we already have that branch ready to go. All right, let's take a look at pull request workflow in these short-lived branches. When we do a pull request, we can run a workflow, and at the end of that, we can deploy our application into a separate environment for each and every one of these feature branches. Now, when these short-lived branches, we can merge them into the main branch. And then we can have workflow that will go ahead and build and deploy from our main branch. So this automation means all we need to do is submit a pull request, and the newly running code that is tested on is then deployed. And when you do a merge into master, you get the running application in a certain location as well. But that main branch, what does that mean? Does that mean it will go into production every single time? So that is one option, but you never know for sure if the merge is going to work exactly as planned. And more importantly, you don't know if that merge will provide the value to your end users, which is what DevOps is all about. So what we really want to do is test our changes before we go into production. So one way to do that is we can pick these deployments off of main that work and promote them to the production environment. So our main branch doesn't deploy to production, it goes to some staging environment first, and when we decide this specific release should go to production, we can release that. We can create a release branch and promote that specific change all the way out to production. Now, there's a number of ways to do trunk-based development, and all of them have their pros and cons, and this just happens to be one that I like. There's also a lot of different ways to promote these deployments into production. The important thing is you should be deploying the exact same artifacts from one environment to the next, right? So I said this carefully. Make sure you listen to what I say. You shouldn't have to rebuild. We really need to use the exact same binaries that we deployed in our staging environment and promote those exact same binaries into production. All right, so yes, there are a lot of ways to do this promotion. But one super cool way that I want to show you all is using a technique called ChatOps. ChatOps is using your chat application, whatever that may be, to control your deployments in a nice way that keeps you in the tool that you're using in your collaboration. So next, we're going to implement ChatOps. We'll use GitHub Actions, since our code lives in GitHubs, and we'll deploy using Azure App Service, since our app is hosted in Azure App Service. And of course, we're going to use Microsoft Teams as our chatting app. And as we saw in the Getting Started with DevOps session, Microsoft Teams is an amazing collaboration hub for Tailwind traders. And we can add even more collaboration features into it by implementing ChatOps through Microsoft Teams. So first, let's look at how we can implement something like this with Azure App Service. Now, App Service has this really cool feature called deployment slots. You can think of deployment slots a bit like a shadow version of your app. So it shares an app service plan, but it's a completely new instance of your front end. But you can direct some traffic to it. So it's a great way to deploy your application because it's essentially you're deploying into production, but it gives you a chance to test things out before pushing it live to all of your users. Now, initially, maybe you have 100% of your traffic going to the production slot and you deployed into the staging slot. Then you can test out the staging slot, and when you think everything looks good, that's when you can swap those slots around. So now all the traffic is now being redirected into your staging slot, and what was your production, that can now be your new staging slot. So this is a really nice way to implement a blue-green environment. And swapping slots is super easy too. You can do that from the Azure Portal UI, or you can use the Azure CLI. Another thing you can do is is direct some of your traffic to the staging slot. And this will allow you to test it and let some of your users see the new code just to make sure everything is okay. And if it's not, only a small portion of your traffic saw that bad code. And it's easy enough to swap that out, right? So next, you can slowly, if everything's working, you can slowly open that up traffic to more traffic and then to more traffic until eventually 100% of your traffic is now using that new slot. So something like this is you can use for canary deployments, or this is also like doing safe deployments. And using slot is a great way to implement this. You can also implement this in different ways, like using feature flags, but slots, super powerful. You can totally do canary deployments and also safe deployments. But how are we going to trigger this swapping, right? We're going to do that inside of Microsoft Teams. As we saw in getting started with DevOps, Microsoft Teams is a great hub for team collaboration. It's not just for chat, and it's not just for calls and sharing documents. There are lots of extensibility points that allow you to really use it as your hub for anything project related. Now, there are piles of wonderful stuff available with conversational bots, with customizable tabs, messaging extensions, so on and so forth. But for our purposes, we're going to be talking about connectors and webhooks because that's what we need to really integrate with GitHub and Azure to help with our delivery, our software delivery. And now we can do all of this without leaving Microsoft Teams. Also, we'll be using a cool features inside of Teams. Instead of just dumping messages in the channels, we're going to use something called an adaptive card. So these can give you powerful interactive containers so you can actually do work and make things happen rather than just see status updates. All right, so here's the plan. When a PR is merged into the main branch, this is going to kick off automation and will deploy the build to a staging slot. Next, GitHub will go ahead and send a message to Teams that a new deployment just occurred using an adaptive card. And this will say a new deployment occurred. It will have links to the new staging slots, and we'll have a button that will promote your changes into production. So after seeing this message in Teams, you can go directly to the staging slot, test everything out, make sure everything looks good, and if it does, then we can click that promote button, and this will trigger the promotion or the slot swap, and then the staging deployment will be promoted to production. All right, super cool. Let's take a look at this in action. We'll walk through this workflow using Day1 Trader's website. Again, we need to make some changes, but this time we'll be a little more safe with our deployments. We'll deploy into a staging environment, test it out, and then promote those changes into a production environment. In fact, we're going to take this one step further and go through a pull request first. So here's our website again, and this time the finance department came to us that this free shipping that we're doing, that's not going to fly, man. It's costing us too much money. So instead of free shipping, they want us to change it to cheap shipping. All right, easy enough. I've made those changes already. And if we jump into VS Code, we can see some of the changes that I've made. And I've made these changes in the cheap shipping branch. And when I checked this branch in and issued a pull request, this kicked off my automation, which built this branch and then deployed it into staging. So this is my production branch. And as you can see, the changes did not deploy to production. It deployed to my staging pull request site first. So here you can see in our Teams channel, GitHub alerted us to the pull request. And that came from the GitHub Enterprise connector. So here's where we configure our connectors, and we configured this to send events from GitHub, our project in GitHub, to this specific channel. All right, so now, if we click on the View in GitHub button, this will allow us to view the pull request directly in GitHub. And here we can see exactly what changed, and in this case, we changed free shipping to cheap shipping. All right, we can also see this build kicked off our pull request build workflow. So clicking on the details, we can see exactly what happened in this workflow. Now, part of this workflow, it deploys this to a pull request staging environment. And what we want to do is check that out, make sure it looks good, and see if this is something we want to promote to production. All right, so let's go ahead and jump to our pull request staging slot. We'll go ahead and refresh this. And free shipping then changes to cheap shipping. Yay! Our changes hit our pull request slot. It looks good. So what we want to do now is merge these changes into the main branch. So let's just jump back into Teams because now we can go directly to our pull request, and we'll merge this to our main branch. All right, so once we merge our changes, it's going to, of course, kick off our actions. And here we can see that it kicked off. And now we can jump in here and we can watch it run through. All right. There's an extra step configured now where we send a message to Microsoft Teams. So yes, it builds, it tests, it publishes, it deploys it, but it also sends a message to Microsoft Teams. So what that's doing is we're sending a message from here, hitting a webhook in Teams, and it's sending an adaptive card to our chat ops channel. So if we jump into the chat ops channel, we can see that adaptive card where it says deployment has completed. And there's also a deep link to the commit which triggered this automation. And if we click on this, it will take us directly to that commit in GitHub, which shows us exactly what was changed. Now, going back to that adaptive card, we can click on the open staging site, and this will take us directly to the staging slot. And you can see cheap shipping has made it to staging. Awesome. But it still hasn't made it to production yet, right? Hasn't made it to production. So now we can jump into the Azure portal, and in theory, we can just swap the slots here, right? But jumping around in different tools is kind of a pain. Plus, in Teams, we have that adaptive card, where if we press that Promote to Production button, if we click it, it's going to hit an Azure function, and in the background, it's going to use the Azure CLI to swap slots. And now we get an updated card that tells us the application was promoted to production, with a button to see the production site. So let's go ahead and click it. This will take us to production, and now we can see, let's refresh this, instead of free shipping, it's now cheap shipping. It's made it all the way into production. Hooray for that. So we're looking pretty good now. We have continuous integration. We have continuous deployment workflow. And it's using GitHub Actions, Microsoft Teams, and the power of Azure to make sure we're deploying our application out to Azure. But our production environment is now protected, and we have an opportunity to check it out in a staging environment before we promote those changes to production. All right, one thing we pointed out a bit in these demos is the idea of keys, secrets, and credentials, right? When you deploy your application, there are places you're going to need to pass in passwords and secrets to authenticate. For instance, when we deploy to Azure, we have to be able to authenticate with Azure. There are also keys and settings and credentials that our application needs just to run, things like connection strings, API keys, and these need to be set during deployment. So all of this stuff should not be in source control. In fact, GitHub will alert you if you accidentally leave a key in source control, right? Because now you're leaking out your secrets to the public or to a lot of people that shouldn't have them. So how do you handle secrets? Now, right out of the box, there are GitHub secrets. So in GitHub, for each repository, there's a place to securely store secrets that can be used in your workflow. Here, we're using it to store the publishing profile for our deploying to our staging site. Now, we have to create the secret out of band, so it's not in your code. It's safely stored in a separate location. Right. So to set this up, it's easy enough. Again, it's specific for your repository. You go into the settings, secrets, and here you can create a brand new one. Now, if you do this, you'll notice that there's no way to view these secrets once you stored them. You store them, they're encrypted, and now no human being will ever be able to look at them again. And even if you use them in your GitHub Actions, GitHub does its best to strip them from all the log files, so you still won't be able to see them. But as good as this is, there are some limitations. The secrets might be used in a number of places. So if they're changed, now you're going to need to change it in every single repository that uses this secret. And the key here is you got to remember where they all are. So this is particularly important in the case of an emergency or a security incident where you need to kill all your creds immediately and quickly recycle all of your secrets, right? Trying to remember where every place that uses them, that's really difficult. If you don't remember every repo, deployments are going to break, right? So it's also generally a good practice to cycle your credentials often. So now the person in charge of controlling these credentials, they also need access to every repo that uses them. So if this is your ops team, you can see this does not scale well at all. In fact, it scales pretty badly. So another great way to store your secrets, and not just your secrets, but your keys and certifications as well, is in something called Azure Key Vault. This can be integrated with your other Azure resources, giving us a central place to manage everything. So Azure Key Vault allows you to have a single point of control. And it's also managed by Azure Active Directory. So sensitive information is centralized and it's managed by the appropriate people. And the workflow simply pulls these credentials just before they need them and is using another Azure credential that can be controlled centrally as well. So let's take a look at what this looks like. Here's our workflow that uses Key Vault action from Azure to retrieve the Docker password from a specific Key Vault. It's stored in the output variable with the ID kv secret action. And then in the next step, we use that stored secret with the Azure Docker login task to log into Docker. So if we need to cycle our secrets, all we need to do is make those changes to our secrets in Key Vault. We don't need to make any changes to the workflows or in any of our repositories. They will just work. They will just pull those secrets down and everything flat out works. All right. So let's take a look at this in action. Again, we'll be using our Tailwind Traders website. So we're going to jump back to our first demo, and just after we changed our workflow to use Docker for our deployment. So what we're going to do, what currently it's doing, it's using a Docker password that's stored in secrets in GitHub. And we want to change that by pulling these from Key Vault versus using it directly from GitHub secrets. So to do that, we'll add a couple of actions here. The first, we're going to go ahead and log into Azure, and we'll use the credentials that are specific to this application. So if they need to be reset, we can just reset it for this specific application. After logging into Azure, we want to get the Docker password from Key Vault. So we'll use the Azure get Key Vault secrets action. And finally, in our Docker login, instead of using the Docker password from GitHub secrets, we'll use the secret from Key Vault by referencing the output variable in Docker password. So again, we're logging into Azure, we're getting the specific secret from Key Vault, and then we'll use that secret, and then nothing else has to change. So let's go ahead and commit this, and we'll push those changes back up to GitHub. Okay, so once those changes hit GitHub, it's again going to kick off this action using this specific workflow, right? So this right here is Key Vault. You can see we have our Docker password, and we can also see that this is a place that you can store your secrets and also your keys. Now, it turns out I don't have any secrets or keys or certificates, but if you had some, you would store them here, right? All right, so we have no keys, we have no certificates, but we do have that one secret. All right, now jumping back into action, we can see that our action has kicked off and our workflow is now being triggered. Now, if we jump into this workflow, we can see that it's running. And again, it's not doing anything magic here, but this time, instead of getting our secrets from secrets in GitHub, it's pulling the secrets down from Azure Key Vault, and then it's going to go ahead and use it. So we've seen some pretty cool things with GitHub Actions and Microsoft Teams and Azure App Services all working together to enable us to deliver change to our customers. But we can do so much more too, and our imagination is really the limit here. So we can do all sorts of stuff in our automation tools. So for instance, maybe we want to rotate the credentials in Key Vault for our app. And maybe we want to do this when an admin just asks the team bot to do it. Guess what? We can do that using integrations with Teams to hit the Azure API, rotate the credentials. And the next time we deploy our app, guess what? Everything just works because our workflows pulls these secrets down from Key Vault. Maybe we want to automatically build a new developer environment and fork a repository into their private repository based on a properly formatted issue in GitHub Issues, right? So this isn't something that I'm just making up. I've actually seen this happen. So there are people where if you create an issue in a specific private repo, it will automatically create all of your resources up in Azure using ARM templates, and then it will fork that repo into your own personal account. So now you're ready to make changes and fix this particular issue. All right, we can also do things like pull the commit messages since the last production release so we can automatically build release notes, right? So our imagination is a limit here. With Actions, we can have workflows that automate just about anything inside of GitHub. There's also a repository dispatch event that can be used for any external application. So if you registered this correctly, any external app can now fire repository events to GitHub, triggering your actions. So we've covered a lot of stuff here. So to summarize, add CD to your pipeline, whether it's continuous delivery or ideally continuous deployment. I think it's important to continuously deploy somewhere. It doesn't have to be production, but continuously deploy to a test environment is super valuable. It means not only have you built your app and your tests passed, but you also know your app will deploy successfully. And moving to production will probably work because you've already done this in your test environments. And if you use containers, you can feel even more confident things will just work. Ultimately, though, it's about protecting production. You don't want to deploy all your changes directly to production, and one way to do that is using ChatOps. By using Microsoft Teams and its integration points, you can send adaptive cards that will allow people to do work of promoting changes to make sure the changes are working. And finally, I think it's really important to centralize your secret storage like using Azure Key Vault. Yes, you can put your secrets directly into GitHub Secrets, and you absolutely just don't want to put it in source control. That's the key. But putting all of your secrets in Key Vault, that means you can manage them in a much cleaner way. And if you want to learn more about what we've talked about today in this session, go here and do this Learn Path, which will teach you how to author automations using GitHub Actions. Similarly, if you want to learn how to collaborate with teams and you want to learn how to do that, here's another great Learn Path that does that as well. So go ahead and check that out. Also, there are plenty of documents on Microsoft Docs, so go here to see all the docs about the Teams integration and writing those Teams integration. And if you want to learn about Azure Key Vault, jump in here, and there's all sorts of docs and learn modules about Key Vault. And finally, thank you all so much for joining me. Hopefully you learned some great DevOps information, and stick around to the next session because we're going to do even more cool DevOps. Thank you.